Hey guys, how's it going? Everything cool? I just want to go back a little bit to the entrance, um, reproducing DAO attack. So it turns out we spent quite a little bit of time going over this, but the problem was that the DAO contract that we're using had a problem, so it wasn't really the right contract. But now let's go over the how to fix it. So we can actually reproduce the whole attack. Okay, so if we look at our DAO contract here, you're gonna see that in our withdrawal function, we have these balances message.sender being decreased, each one of the transactions, right? Now, one maybe misconception that people may have with reentrances is that you only get a certain amount of code executed. So we can say, okay, so if I'm doing a reentrancy over this function, the code will only run until this line, which is the reentrant line, right? And then over the receive function on the attack smart contract, I'd be calling this again and creating a chamber of curse. But this is not what happens. What happens is you have the whole state execution. And right here, what we're doing that's keeping this from being reentrant is doing a tight control of the balance of the user on storage. So this is not a memory variable. This is all done on storage, and because of that, what's gonna happen is that this ain't gonna work. So let's now finish this. Let's actually have the contract. Let's take a look at what happened with the DAO contract, so we can have a code that is a little bit close in the sense of the withdrawal function. Okay, so 1 second. I'm gonna go for a friend sent me that, so I'm just gonna get the link. Once again, the idea here is just that we research. This is not a course. We're just going over the topics and reviewing. Okay. So my friend Baggy sent me a link that we have the withdrawal function for the DAO. And what I want to show here is that the withdrawal function would really set the balance to 0 and will not work with a withdrawal value, with an amount value. So let's make the function look a little bit like the one in the DAO, and let's proceed with the exploit. So first change we're gonna make here is remove the amount, which is not needed anymore. Thus this line here is also not needed. Um, um, Once again, sorry about that. Okay, what we're gonna do now is whenever we're trawling, you're gonna be calling pretty much whatever is your balance. So we're just gonna read your balance, and that's what you're gonna get, on the as the sender calls, and you're gonna be set to 0 on storage. Okay. Now we're gonna try to run this code. Let's make a small test, to see if this works. I'm gonna take this to remix, and on remix we can take a closer look at it. Um, my screen is a little bit too big from testing. Let me just take a second to adjust that. There we go. Sorry about that. Okay, this. Yeah, I'm also gonna decrease here a little bit. That is too much for me. Awesome. So what I'm gonna do is simply gonna come back here, and I will replace the implementation that I had done before with VS Code for the DAO contract, redeploy it, make an investment, and try to steal it from another account. Um, First thing we do here is replace the DAO contract. I was testing a little bit before, been testing, so I'm just gonna remove this funks here, these contracts, and then I seem to have a problem. Let me see here. Yeah, there's no amounts anymore. Now pretty much we're gonna see if the balance of the sender is different. It's 0. We actually don't need. Let's take a look at the contract in the DAO. There's just a send. There's no. It's just a send. There's no, not even checks for nothing. So let's just do the same. So this is simply going out, just like that. And man, really, spaces. Okay, this is giving me the OCD. 1 second. Sorry for that. Okay, this is better. So now we're just taking the balance from the user and updating the balance. And let's check if this is a entrant function or not. Another error here. Inspected pragma, probably another. Yeah. Okay. So I'm gonna start deploying the DAO. And after the DAO is deployed, I'm gonna do an investment of 10 Ether for my address. So let me just go here real fast, 10 Ether, and investing for my address. There we go. Now let's go for the attacker. And with the attacker, I'll deploy the DAO hack contract. I'm just gonna take a look at it. I'm counting these interactions, you see, because I thought for one point that could be a gas issue, you know, or some strange overflow. So what I'm gonna do is I'm gonna remove these, not really remove, but I'm gonna move part of the attack. So part of the attack now happens here. Okay. No, I don't really need to calculate the DAO balance. I don't really need to look at this here. The only thing I want to do here is start the attack. So just start the first withdrawal. Okay. And my payload would be pretty much executed inside this receive function. For me, also I'm gonna remove these counters, they're not needed. This is all experimenting with different things. What we're gonna do here is pretty much make sure that the balance of, you know, address DAO. Sorry for the lousy naming on the variables. It's just that, you know, just hacking. So address DAO balance gotta be greater than 0, right? Simple rule, old rule, everybody likes it. If you wanna say gas, make it different. Then we're gonna withdraw. Keep on withdrawing. Now, let's check how this is gonna work at this point now. And I'm even gonna leave it here for now. So my attack function does the investing, does the withdrawing. I set everything here, and my receive function does the withdrawing again. You know, the entrance style. So let's deploy the contract. And I do need to send some money to the contract. I'm sending. Okay, I'm gonna work with message value. So here will be message.value. Okay. So I don't need to send money in the constructor, but I can send with the attack function. Seems decent. So let's deploy it. Of course, can't deploy it. Constructor is payable. There's no ether. Let me just do this and try again. Okay, looked like that was not the problem. The compiler is probably telling me something here. Um, what, where am I screwing? I'm forgetting a semicolon or something. It's literally telling me the line, right? This is ridiculous. Okay, let's go. Now it's gonna work. No, 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 no. Why? Let's wait a little bit. Is anything popping out? Let me try again. You know, development is a resilience game. You need to be resilient. Okay, so the idea here is to get the ether. So we're gonna start by doing a one ether retroning and see what happens. Let's go for it. Nothing much. Looks like nothing much. I think this is not. Is not the ancient still, is it? Where's my. Okay, looks like I have a reentrant function here because I'm battling hard with that dude. You know? Great Frank Baggy, thank you for giving us that thought. I'm gonna turn this into bigger than 0. Like, I can probably just say that, right? Okay, let me try this guy. Guys, this is research, okay? I am gonna be here, making 20-minute videos to building everything beautifully. It is what it is, you know? I don't even want you to do this thing. I don't even want to do this thing. What's the problem with this require, man? No matching declaration. This is not a boolean, right? It's gonna be bigger than 0. And okay, so here we have a entrant DAO. Let me erase our contracts. Take a good look in the exploit contract. You see all the excitement died in my voice because I've been literally all day battling with a broken contract. And now that I have one that's working, it's not working too. Okay, so first thing I'll start investing 10. I kind of deployed everything from the same smart contract. That's not really a problem. That's not really a problem, is. Okay, let's not deploy the DAO. Let's just do the investment now. So I'm gonna copy my address, paste it here, and I'm gonna give it maybe 10 ether. And now a filthy hacker will come. Filthy black hat will come and will deploy a DAO attack contract looking at the DAO, and he will send 1 ether to his attack function that will then steal all the ether in the DAO, because what happens is, as we got in the withdrawal function, and even though we did this update here, we have a require, so atomically the function came here, executed the code again, and I was able to get in forever, pretty much train the contract, because the balances were never updated to that point. Interesting, you can see that the execution is here. What is it? The receive function, so we have the attack that does the first investment, does a withdrawal. Withdrawal comes, sends ether. Here atomically I'm calling receive. Receive is calling withdrawal in steps, right? So that update never happened. So yeah, it was really interesting battle with this thing. Okay, it was really interesting, if we can call it like that. Um, I will bring a more structured, maybe easier, smaller video on the entrance thing. It could be really simple to explain, but as we're trying to build the whole thing, you know, takes a lot of testing. Thank you so much, and this is the video. See you guys.